Here's a video for section 4.4. We're using corresponding parts of congruent triangles. And what we're going to say about those is we're going to take our proofs and maybe go one more step than we're used to. But I'll show you all about that. We're using the fact that corresponding parts of congruent triangles are congruent. So that's what we're going to look at here. And here's the basic knowledge for today. If you know that two triangles are congruent, you know that every pair of their corresponding parts are congruent. So if I can say that the triangles are congruent, I can go one more step and say that every piece of those congruent triangles would be congruent as long as they correspond, right? So quickly here, we have two triangles. They want to know, is this triangle congruent to this triangle? If you take a look in this left-hand triangle, we have side, side, and angle in between. We have that same angle on this triangle, but we don't have those sides. All right, so this is going to take a little bit of transitive property. If you look at this middle triangle, I have the two same side markings on this one, and this would have to be an 80 degrees if you look at the numbers in the triangle. We need 180 degrees total. So what we have in these two is that triangle ABC is congruent to triangle DEF by side angle side. The middle one is also going to be congruent to the right-hand one. I have an 80 and an 80, a 38 and a 38, two angles and a pair of sides. So that would mean that triangle DEF is also congruent to triangle GHI by angle, angle, side. Right? So the original question is if the first one and the last one are congruent. Well, by transitive property, they're both congruent to DEF, so they must be congruent to each other. So just a quick one there, just trying to show you that transitive property extends to these congruent triangles as well. Right? Here's the main point for today. We're going to be looking at still the same proofs that we've been looking at. The pictures look the same, but what's here is different as far as what we're trying to prove. Usually we're just trying to prove that the triangles are congruent. Now we're trying to prove that KB is congruent to AC. We're looking at just parts of the triangles that would correspond. So let me show you how it works. If anything goes too fast, just go ahead and pause that video and get it written down. We know that given step, all right? They gave us two pairs of angles this time, all right? This is also a triangle with some shared sides, so we do have some reflexive property. So we know that there's one pair of sides, two pairs of angles. This is enough to say that the two triangles are congruent. All right, so you might have to come up with your own congruent statement this time. This is a good example of one. Okay, the reason these triangles are congruent is angle, angle, side. Okay, this is normally where we would stop, but we're going to keep going just a little bit further here because we haven't said what they want us to prove yet. They want us to say that KB is congruent to AC. Well, if we know the triangles are congruent, that has to be true. The reason for it looks really long. It's saying since the triangles are congruent, the corresponding parts are congruent. So I would just write that abbreviation for that reason, CPCTC. If you need to take a second to pause the video and look at this proof again, I would do so right now. Otherwise, I'm going to be moving on to the next one. So these proofs are pretty similar each time to what we've been doing. We're just going one step further, right? So notice, same setup if you look at the pictures. They gave us two pairs of angles, or two pairs of sides, I'm sorry. There's going to be a vertical step, but what they want to know is that another pair of angles are congruent. They want C and E, which we can't say yet, but we will be able to once we say the triangles are congruent. So we have a given step. Like I said, we have a vertical angle step because our picture looks like a bow tie like that. All right, so a good way to name it this time, CAB and EAD. Okay. That would make the triangles congruent. Okay. So I would actually write CAB right here again. Sorry, just trying to make sure that the letters are correct. Triangle CAB and triangle EAD. There we go. By side angle side. All right, and then like I said before, this is where we would stop, but we're going to go one step further to say that the angles we want to say are congruent are, and then the reason we would use is CPCTC. Right? So same three steps that we're used to up top, but one last step to use CPCTC. We can say any pair of angles or sides that are corresponding are congruent. Once we have the triangles congruent, we can use CPCTC. right? Looking at this one, it says a Greek philosopher is said to have developed a method to measure the distance to a ship at sea. He basically used congruent triangles. Okay, so I'm not going to read through all of that. All right, but that's how it worked. They want to know how far would the ship be from the lighthouse here. Okay, and really, I'm just going to look at it as another proof. So here's our picture. Okay, we just made a little bit more of a real life example. Want to know how far would that ship be from that lighthouse? Okay, well, what we know, okay, is what's given here. I didn't write it anywhere else, but I'll write it here. Okay, this is all stuff that's just given. All right, we know that TRS and TRL are right angles. Okay, and then we know that RTS is the same as RTL. RTS up top is the same as RTL. Okay. All right, in this picture, we have a reflexive step. TR is TR, that's like the lighthouse. Sorry about all the scrolling up and down. Picture's just a little bit bigger than I thought. Okay, we're gonna take another step to say that the right angles are congruent, because that's always true. All right angles are congruent. Okay, and then what we'll have there then, we have a reflexive step. We have two pairs of angles congruent, and a reflexive step. This is angle, side, angle in these two triangles. So we name the triangles. What they want to know is, okay, why does this method work to look for a ship at sea? Because RS should be the same as RL. That's saying that from the shore to the boat should be the same as the shore to the tree, and it'd be easy for me to measure the shore to the tree. All right, so let me show you that again. Again, you can pause if needed. Okay. All right, so I'm just about wrapped up here. When we're looking at triangle proofs, we're just looking to use that last step for CP/CTC. Sometimes the way you know is when it's in that proof statement. So one last time, okay, we can do this one from scratch, and then that should be the last thing I have for you. All right, AB is congruent to AC, that's given. I know that M is a midpoint here of BC. Okay, they want to prove some angles congruent. So let's get that stuff in the given. Okay, we know that AB, that's one pair of sides, congruent to AC. All right, we know that M is the midpoint, so that leads us to a step we always take. Always ends up being the same. Okay, so we can do that definition of midpoint step right away because you're probably itching to do so. All right, we've talked about that. If it shows up in the given, you have to use that word somehow, okay? Well, if B is the midpoint, M is the midpoint, of BC, that means BM and CM should be the same length. So BM should be the same as CM. Okay, all right, oops, bad handwriting there. Okay, BM should be the same as CM. Okay, the other thing we can do here is a reflexive step. This is going to be a side-side-side proof. We haven't seen that in a while. All right, but we have MA would be the same as itself by reflexive property. And what we have then are three pairs of congruent sides in these triangles. So I have side-side-side congruence. So let's write our congruent statement that would normally be our last step. AMB would be congruent to AMC. All right, the reason that they're congruent is side-side-side. And then just to wrap this up, anytime that happens, I can say any pair of angles I want or any pair of sides I want, but this time I have all the sides already, are also congruent. So A and B, since they correspond, would be congruent to AMC. So we said these two angles are the same. Okay? The reason that's true is because they correspond and the triangles are congruent. So corresponding parts of congruent triangles are congruent. Okay? So that might be a lot of information. Feel free to watch any of those proofs again just to see them and how they work. Okay, but 4.4 is all about CP/CTC. Sorry about that. Okay, corresponding parts of congruent triangles are congruent. Okay, why don't you move on? Make sure you ask any questions tomorrow. We'll get that worksheet and give a couple of these a shot.